My name is Dmitry Bach. I'm a scenario creation analyst at FME Software, and I work on really cool new things that our company adds to the product. So in the last maybe 2 years, I do a lot of augmented reality stuff.
Mm-hmm. For anyone who doesn't know Dmitry, he has a very cool job here. He has like a Slack channel that he'll post some of the things he's working on, and it's one of my favorite things to check like every day because he's always posting these just cool things he's done with FME that just looks like so much fun. So Dmitry webinars are always one of my favorites. And yeah, and I'm Stephanie. I run the webinar program here at SAFE. I've been here about 8 years, and I'm going to be helping to moderate the webinar. So we have a couple different places for Q&A. So please chat in your questions, and I will relay some of those questions to Dmitry when we hit those spots. And in the meantime, if you have any questions about like GoToWebinar or the platform, you can find me behind the scenes. I'll also be chatting out some links as we go. There's a couple slides where we share YouTube videos, and depending on your internet connection, it might have a bit of a lag, but I'll chat out the YouTube links as well, so you can always view them in YouTube instead.
Yeah, actually, that's the nature of AR. It's really hard to show in any other way rather than just through videos, because we usually do them outside in different locations. Well, I imagine we will do that one time in the future.
Yeah, in the future, maybe when people can group together. But that's a good point, actually. We're doing an AR webinar. Yeah, one day we'll have to find a way maybe to do it kind of interactively. That's not a bad idea. Cool. Okay. All right. Let's kick it off. I'm going to mute myself and kind of pop in and out.
So today we will be talking about augmented reality opportunities, how FME work with AR, why FME or SAFE software offering is different. The highlight of this webinar are user scenarios, user use cases of augmented reality. So in the past, we made these webinars or wrote blogs about, well, actually my games with AR, but this time I'm really glad we have some customer stories for you, and then we will answer your question. So as you can see, this webinar is recorded, and we will share the slides, the links to the videos, and the workspaces later. So as I said, so it's not just fun anymore. Now we really see that companies are beginning using augmented reality for business purposes. And that is happening mostly because of the devices become stronger and stronger, more powerful. They get more sensors, such as LiDAR, for example, and similar technologies. And you may ask, for example, why LiDAR? And this short video shows it quite clearly. So this is Lizard in my home. On the left, it was made with just iPhone XR, and on the right with iPad with LiDAR. And you can see occlusion works really well. His waving hand goes behind the wall because LiDAR can sense the scene and display the picture properly for you.
Yeah, I like his Christmas sweater. Cool. Yeah, so I'm thinking like some of you are definitely intrigued by AR, which is why you're here. But you might be thinking like, okay, I see how AR can make cool videos, and I see how it can engage people on apps like TikTok, but I have yet to understand how AR can actually apply to my job. Like, what are the opportunities for AR, either to make my job easier, provide my company value, or provide my customers value? And that is what we are hoping to cover in today's webinar. And we're hoping that our user stories will inspire you with some of those answers. So speaking of cool videos, Dmitry, what is going on in that video?
Well, that is actually quite easy to create for everyone with iPhone. So, and I'm sorry, Android users, Apple is doing really great job in bringing augmented reality to their devices. This is a USDZ file, which is just a native format for Apple devices to view augmented reality. So you don't have to install anything, it just works there. To create a file that supports augmented reality, you can use, for example, a Reality Composer. Again, it's a free Apple app for creating things like you see on the screen. So if your iPhone is like 3-4 years old, you probably already can do such things. But today we will be talking about the use of augmented reality for, well, other purposes, for cities and other organizations. So what are the benefits of augmented reality? So you can see how your data fits into the real world. Of course, you can take a tablet with yourself or even a paper map and, well, get the idea what is going on around you. But in case of augmented reality, you see that data, not on a screen or not on a paper, but just around you. And in that sense, you can say that augmented reality is an ultimate QC or QA tool, and I will show a picture where you can see it right away that when data mismatches the reality. Then, of course, you can see things that are hidden, something behind a wall or under the ground. Again, we will see those examples. And we thought that augmented reality could really help you with field work, where it just guides you where you should, do something on your location. And again, we will show an example where a customer example or a partner example where that is possible. And of course, when people see that, your customers, your audience see that, they get really excited because just because it really looks cool. So, and yeah, we thought we can use this again here. So we don't just inspect our data, don't just view this data, we experience it. We surround ourselves with data. We basically live inside it. So that's what we mean when we say experience the data. Maybe just a couple of words about Safe Software for those who are new. And I hope we have a few new people here. FME consists of a few products. FME Desktop is a desktop application where you build your workflow. You define how the data should be transformed. So we support hundreds and hundreds of different formats, which we can bring into this workflow, this graphic environment, somehow transform it, change geometries, change attributes, change or measure relationships. And then once the data satisfies the conditions of the destination, system save to that system, and then that's how it all works inside on a desktop level. So then, of course, we can take it on a whole new level with FME Server, where we automate how everything works. So then we have a concept of triggers, and that can be an email or a change in a folder or a schedule or a webhook. A trigger runs a workspace or some other action, and then that action will happen. So, for example, an email arrives, a workspace starts, it runs, processes data, and then sends an email reporting that it was successful or maybe it was a failure. So we will know everything about that. So, and then we have a couple of mobile apps. One of them is FME Data Express, which is a way of talking to FME Server and FME Cloud. Well, FME Cloud is FME Server hosted in the cloud, so you don't have to deal with all the hardware problems. So we will take care of all of that. So FME Data Express is a rich client which allows talking to FME Server, running the workspaces, and it also allows using the mobile device sensors to enter data. For example, you can take a picture and submit it as an input to FME Server. And FME AR, it's another app that can open FME AR files. So in that respect, FME AR is a little bit different than all other formats that we create, because usually we just in the middle between between the source system and destination system. In this case, FME AR is the destination app for which we create data. So maybe I will show quickly how FME Desktop works. I will create a simple workspace. I will switch to, I will just create a new one so that you see how it all works. And I will show a new transformer that we added recently. So I have a data set of underground utilities in shape format for the city of Coquitlam. It's a city here in Lower Mainland, close to Vancouver. I will take just a single layer just to show you the idea how it all works. And I can run this just to see what I have, what kind of data this is. Let's inspect it. So lots and lots of mains under the surface, and you can get the background map. So, well, I did a lot of business trips this year, but mostly of them I just did on my feet, walking from this area to this area for doing some AR stuff. That's where I have the data set to play with. And usually I go through the forest like that. But anyhow, we will pick a location right here. For example, well, let's take this intersection. I will copy those coordinates and create just a point here. So I will paste those coordinates here, just X and Y in UTM 83 zone 10. And I would like to buffer this area because I don't need to visualize 12,000 pipes right away. It makes no sense. That will be a huge AR file, but I cannot see more than, like, a block away from my location. Say I will create a buffer 50 meters, and I will clip my data set with this buffer like that. So I will get only the pipes around my location, and then here I will place our new transformer pipe replacer. And here I will use an attribute to specify the diameter. It is the diameter is in millimeters, I believe. And then we need a radius, so I will divide it by 2 and by 1000. Okay. And I also would like to set some color on these spikes like that. So it's very important when we create AR files with FME to give all the appearances their unique names. So that's what I do here. So if you don't do that, you can lose the colors in your output. Blue color, and that will be it. So I can add a writer. Like that. Connect it. And we are ready. So I don't need actually to create this file at this moment. I have some videos, and I won't be able to show you this particular output because it takes about 10 minutes or maybe 15 minutes to get there. But I will show you the output in Data Inspector. So here it is. We can see that those are pipes. And we can see that diameter changes. So, and here probably we would have a manhole. So it will look very differently, much richer if you add all the layers that you have there. So that's that's how it works.
So you can actually view those pipes in AR?
Yes, yeah, and we will see these pipes in AR. So those are really pipes. You can see them. I didn't specify the inner diameter, so that's why they are, well, not actually pipes. They're cylinders, but
right.
The transformer has another parameter here for inner radius, and then you can have a real pipe.
And then is that how you get the pipes in the correct location?
Yes, those pipes are in correct location. For FME AR, you don't need them to be in their correct location because AR outputs relative to your current location. So you will be a center of that tiny world that you create for yourself, and the pipes will be created relative to your location. But FME Writer takes care of that for you.
Very cool.
So let's move back to our slides. So we talked a little bit about FME Server, and for FME AR, that's probably the optimal or the best workflow when you can use FME Server. Because as with this workspace, you can see we have lots and lots of pipes. And you can imagine that with all the infrastructure that we have under the ground, we go well over 100,000 objects. And you don't want to transform all that data into augmented reality and then maintain two data sets. So ideally, you would just go where you need to go, and you may not even know at the beginning of your day where you will go. Submit your location from that point and get back the AR file only for that location. So, and that's what is happening on FME Server. Instead of creator, we will just submit a URL that comes to this workspace, a URL with coordinates latitude and longitude taken from GPS. It comes to this workspace, runs it, and streams back an AR file for that location where you are. That's all. That's why I'm saying that, well, FME Server is really a nice way of creating augmented reality for cities and organizations that have lots of assets spread across a large area. So again, that's a simple workflow, and that's the workflow that we think is ideal. Submitting location, processing it in the cloud or on the server, the company-run server, and getting back something like this on the right. So those are the benefits of AR created with FME. So we can always get the latest data. So if it was changed just a second before we submitted our request, it will be reflected in the data. So then we really don't care how complex your input format is, because we can, as long as we can read your data, we can transform it into AR. Again, we don't, well, you don't need to know any coding for creating that. So basically, you have to imagine the way from your source data to your destination. So I have my lines. I have to clip the area where I work, one step, clipper. Then I need to make pipes, pipe replacer. So the lines are replaced with pipes. Now I need to color them, set the appearance, and now I just save it to the destination. Of course, we also have a huge community, and if you're looking for help, you can ask a question in our community, and there's a good chance that they will answer much faster than safe support, because we have users all around the globe, from Japan and New Zealand to Canada and Brazil and everything in between, and they are always ready to help with your questions. So now let's talk about well, actually what is going on here with augmented reality here and around the globe. So Stephanie, when do you think was the first AR device created?
Well, I like the answer of it all began with FME AR. I think we could have founded it. Awesome. Okay, I'll give people like 30 seconds here to vote. While they do that, quickly, Dimitri, there was a question from a few people. I missed the file format of the writer.
Yeah, I can show. Yeah, well, it's FME AR.
Okay, hang on here. Just give people a couple more seconds to get their guess in. Yes, thanks for all the good questions coming in. We will have a pause for Q&A fairly shortly, and we'll be able to get to some more of them. Okay, I'm going to close this down and let's see what came in. Looks like the matrix is.
Oh yeah, okay, I can see the results.
I'll also mention that people should be able to adjust the Zoom screen sizes. There's been a couple questions around not being able to maybe see things full screen. GoToWebinar should give you the option to zoom into screens and adjust webcams.
So am I broadcasting again?
You're broadcasting again, yeah. We still see the quiz. So what's the answer?
So 1968. So Ivan Sutherland, I learned about this person just recently when I was reading. So is my camera on? Well, I was reading this book. It's a fascinating person, really. He influenced the IT industry a lot. So the prototypes of the first CAD, maybe CAD systems, were created by him maybe 5 years before that. But let's have a look at this video. It's just 5 minutes.
This more extreme concept was envisioned back in 1965. It wasn't until 1968 that Sutherland, together with a number of his students, created a rudimentary head-mounted display. While I use the term rudimentary in today's context, this device was truly state-of-the-art back in 1968, pushing computer-generated graphics to the very limit of available resources. The head-mounted display was comprised of 2 CRT monitors with mirrors and prisms, which allowed digital wireframe graphics to be superimposed.
I'm not sure why it stops, but you get the idea.
I counted it out as well. That is really interesting.
Over the real world. This concept is, of course, much closer to modern-day ambitions for augmented reality glasses than actual VR headsets, but the technology is closely related.
So maybe once you get the materials, watch the whole video, and you will learn a little bit more about the work of this person. So, but it's really interesting when and how it was created. The sword of Damocles, that's how this device was called, which is, I find, quite interesting. Now let's see FME AR in action. Last November, from the beginning of my field test a year ago, I was trying to put assets under the ground somehow into AR, and it never worked really well. So whenever something is under the surface, just basically does not work. We don't see it as under the surface, we just see some strange movements. And I wrote an internal report saying, we won't be able to see under the surface, that's why we have to place everything on the surface. But I didn't like that answer. So, and then I thought, why don't we just cover the surface with its digital twin? So for example, you have asphalt, maybe just, replace it with augmented asphalt, and then you can do whatever you want. And I will run another video, and I really hope it will work well for you. If not, then later you can do that on your own time. So here I am. That's the very first augmented reality hole made with FME Augmented Reality app. I was so excited, so I, basically canceled all Saturday plans and was creating that, and my expectations were, it met all my expectations, exceeded my expectations. It looked really good, I think. So me walking around it. Some people who are afraid of heights may get dizzy looking at this. So yeah, you can see that was November. So, and when I was a surveyor, in the last millennium, a little bit for a few months, I did sometimes those field works where I was walking around with a big metal hook, opening those covers and measuring everything inside. Sometimes I couldn't find the covers because they were covered with dirt or snow. So having augmented reality for that would be really, really nice. So, and again, here's a trench. You can see that you can place a longer objects. So that all works quite well.
Yeah, I feel like I learned something new about you in every webinar. I didn't know you worked as a surveyor as well.
So, and once I published this to Twitter, Fredrik Johnson from Varberg municipality in Sweden asked whether they could use it for their project. They would like to visualize a railway tunnel under their city. So here you can see it in a 3D picture of that, aerial imagery. And now let's take it to augmented reality. That's what Fredrik and his team created. So this looks like a normal 3D picture. We can look inside a tunnel. But then if you raise the phone, we can see that, well, this is the hole right in the middle of the city. And you can see how how everything works inside AR. You can see an orange spot in the middle. That's we allow teleporting from location to location. That maybe is not very good for real augmented reality with fixed position of the assets, but for making some interesting effects, maybe for viewing things that were taken somewhere far, maybe scanned with a drone, you can use those points of teleportation to view the models. And I really like this part. You can see that, well, the feed don't work that well. So, but that depends. That will change if you have a LiDAR in your phone or iPad. It works much better with that, and we can just expect that the companies will make it better and better with every new generation of their devices. So I also created a local example of the same train, and maybe have a look, just a quick one, because I will return to this model later to show you something new that is coming. That is actually how I go to my business trips this year, through the forest, through this area. Of course, we don't have this tunnel there.
A question came in. Has this been used to look at proposed buildings so that you can stand in the proposed spot and see the impact on the location?
Yes, I did that. Well, we don't have a customer story about that, but I did that for our own office. Our area is being built quite actively, where the new safe office is, and our building is called CC2, City Center 2, and the phase 3, CC3, is another building across the street. And our concern was that it would cover the view of Mount Baker in the Washington state once it's built. So I built the model and went to the roof and placed that model outside where it belongs. And now our concerns can be dismissed. We still will keep the view to the view of the Mount Baker. Well, if I didn't make any mistakes while creating that model.
Nice. Let's hope. It's a nice view.
Yeah. So of course you can use that for fun purposes, for creating games. So just go play with it. I will share the workspaces so that you can easily take it from there and place a hole in your backyard, trying different models, trying different things. I probably will keep this video for you to watch later. You can move to the next slide. Very similarly, you can look behind the wall. So that's a corner in my house. Yeah, now that's my office for this year. So like with everyone else. here is the wall, and I would like to see what's behind this wall. So I will take the pictures of the wall first, and then the wall itself. And here you can see two pipes. And of course, we could try to make them look realistic, plastic or metal, whatever they are. But coming from JS background, I understand. So the language of visualization can be much richer. So we can convey some information with that. So if I would see two plastic, white pipes, it wouldn't tell me much. But if I can color them according to their function, then I get more information. So that's how it looks in real life. And the dog is gone. Okay. Now, yeah.
Oh, I was going to say, I know we talk about this at the end, but we've got quite a few questions about it coming in. Android, they're asking, questions are like, is all of this being done with iOS, and can any of it be done with Android?
Everything what I did was, well, with iOS, because, well, I have actually two devices at home to try this. And Apple, I must say, they do much better job than Google in allowing people create augmented reality. Their ARKit is much more user-friendly to create something with it. They made USDZ format their native augmented reality format. So basically, you don't need anything. You just need an iPhone to see augmented reality. And I will show you maybe an example of that later. So it's basically just works there. We are working hard on creating an Android version. We have an Android version which is 2 years old. It cannot do a lot of things. We hope to publish it very soon. It's just, I just cannot say a date when that will happen. We are working on that. Yeah, we understand the concern of our customers. Yeah, but let's talk about Resnick Infrastructure Systems. It's a company in Israel, and they are the pioneers of AR adoption. They do massive, conversion of data to AR and exploring it where it belongs. You can see that they use the concept of portable hole and the pipes, and they visualize it with all the assets, with valves and all the pipes and everything. You can watch this video later when you get the materials, and you can listen how they explain their work here. But I think it's really fascinating what they do. So they can annotate assets, so add some attributes as labels, and I will show even more what you can do with labels in a couple of minutes. So they visualize here two types of it, water and drainage, I believe. This was an impressive intersection of pipes, like 1, 2, 3, 4, 5, 6 pipes coming together. And of course, they also show arrows that specify the direction of the flow. And it's a flat area in some cases. On the slopes, it might be a little bit harder, but I will show you how it works on the slopes as well. So that's the second customer story. I'm really happy to, well, see those stories. Yeah, so that's a moment for asking maybe a couple of questions.
Yeah, we got quite a few good ones coming in. Okay, this goes back to earlier. Is it possible to clip 3D objects like BIM models?
It's a good question, and the answer is yes. If the geometry is solid, we can clip solids with solids. That works. It's harder with surfaces. It's not impossible, but a little bit awkward to create surfaces.
Okay.
To clip surfaces. Yeah.
What coordinate systems are supported or needed by FME AR?
Well, since it works on your location, all you need is a data set in meters. So if you have, for example, feet, then you have to make a conversion, or inches, or centimeters, so you would scale it. The way we can, specify the location in the world is through a geospatial anchor, where you can specify latitude and longitude of your location, and then the model will know where it should go.
What are you using, your phone or your iPad, to view the models, and is there a difference or any limitations?
Well, iPhone is easy to carry around. So when I go to the forest, I usually just grab my phone and make some AR stuff there, or anywhere with my phone. The iPad, of course, it's not that easy to carry around, but as a device for a professional, I work as a surveyor, and that stuff was really heavy, like lots of things. It's a very, very, very nice experience. It's the picture is so big it's a good 11-inch screen. It's very comfortable to work with. So I have both devices, well, provided by the company, of course, and I really like working with iPad. The limitation is that my phone is now 2.5 years old and it does not have LiDAR, so occlusions don't work that well. Although maybe I should say that FME AR is not up to speed with that, so we are working on that. So the native Apple viewer for augmented reality does much better job with occlusions, with covering the augmented reality with objects of the real world. It's much better in that respect. But for that, it's better to have LiDAR.
Nice. Okay, maybe a couple more. Do the AR outputs work with the HoloLens?
Not our format, but we certainly can have a look how it works. Well, that's the problem, right? So there are much more advanced devices in the world for augmented reality, but they are not still, that popular because of the price. They cost $2,000-3,000, and that's just the beginning, because you have to create the whole infrastructure around that, to transform your data to hire specialists that will maintain that. So it's all cost a lot of money. So it's possible. If it's possible to transform the data to HoloLens, then it's possible to use that. So we can have a closer look. It's just hard to justify creating something for HoloLens if we don't have enough customers to do that. Whereas, well, everyone has a phone in their pocket to carry around.
That's true.
But that would be really interesting to try. Yeah, certainly. When Apple creates their headset, I hope I will get it to play with.
Yeah, I think, Garrett, that's a great question. And I hope that maybe you try out some of these examples and report back to us. If you do have a HoloLens, we'd be really interested to know.
And yeah, I'd be happy to help if anyone has it and can share their experiences.
Yeah. Okay, quickly. So these questions came in about the pipes behind a wall. Do the pipes need to be geo-referenced with XYZ coordinates, or is the scene manually adjusted?
Yes, it's a good question. So the whole thing, all I do there is just use the orientation, and it gets, well, that the sensors and the phones are not that perfect. So I get it approximately right, and I know where the model is. Again, I get it approximately where it belongs, and then I adjust it with my fingers inside. Our kit, the Apple development environment for augmented reality, supports anchors such as a picture on the wall, for example. And we are looking to incorporate that into our app as well. So you would just basically place a picture, for example, a QR code or anything on the wall. You would point your device on that picture, and it will place the augmented reality model where it belongs. So I did those experiments outside of FME AR, and it works not that bad. You still might need to adjust it a little bit, but it works quite well. And yes, that's a good way of adjusting or placing indoor models where they belong. Another way would be to use Wi-Fi triangulation, and we wanted to make those tests about a year ago, but well, in the office, but our office is closed, and we had to pause until we are back. So maybe later this year we will try Wi-Fi triangulation, which can be quite precise. I read, to a meter, maybe to 60 centimeters precision, and that would be quite good.
Okay, maybe you might have answered this, but there's a few questions. So the last one around like geolocation. How do you account for the poor geolocation possible with just a phone?
Okay, so again, yes, the location might be not that great, so you can get another 5, 10, 15 meters. And in this case, well, first of all, you can manually adjust the model. That's why when you deal with underground utilities, you would want to place some on-the-ground assets. So I use fire hydrants as my visual aid. If I see a fire hydrant, it's usually maybe one per block. I can just see it and match the augmented hydrant with the real one. It is possible to connect to external GPS. So I have Bad Elf, which gives me a 3 meters precision, and that helps. I don't have a surveyor's precision GPS, never tried it, and I really would be interested to hear from someone who has access to such a device, how it works. For safe, it's hard to justify, buying $2,000-3,000 device just to try this. So we would hope that our partners or customers would have this and will tell us how it works with this kind of devices.
Totally.
Well,
okay.
Otherwise, it's just your fingers adjusting the model on the screen.
Right. Cool. Okay, let's keep going. We got about 15 minutes here, so sorry, we spent a bit of time on questions, but there were some good ones.
So yes, often we don't have to see under the ground. We have lots of assets. We can have lots of assets on the ground. Our street lights, maybe playgrounds, structures, benches, bus shelters, and we may want just to annotate them and get some information about what's going on there. So here is another video where I annotate the pipes. So the city of Coquitlam, where the data set that I use for my augmented reality experiments, it does not have the third dimension Z, so I just place them on the ground, and you can see it's quite works quite well. You get the idea of where everything is. And here I label the assets, and then maybe I should create a separate video how I create this kind of advanced labels looking like tables. So here I just added some labels for the street lights. So and here maybe looking a little bit into the future. So you can come to this label, maybe see something what is not matching. For example, the pole needs maintenance, or foliage became an issue. You would tap on that label, and that will run a workspace, just another workspace that you would create with FME Desktop, and that will issue a work order for a team, for a maintenance team, and it will just go there, and you did your job. So I mentioned that you can use augmented reality as an ultimate quality control tool, and here's an example where I created a pole, which was, well, I didn't check the table before going to the data set before going to the field. Just when I came there, I saw this. So it's 1,000 meters high, and that's certainly a problem, either with units or maybe with some default value. But you see it right away. And sometimes I can see that I cannot match basically. Well, I see 2 manholes, and I cannot place my model correctly so that they both are covered, because one of them probably was surveyed with an error like 50 centimeters or maybe a meter. So you can see it right there. This is a very good example from the United Kingdom, from our partner One Spatial. It's our partner there. I hope the video will start. I don't know why it's so slow.
It's a little slow to load, but I chatted out the link as well.
Yeah, okay, so they do about 2 million excavations per year in that country, and they create that so-called traffic management plan where you basically specify how the traffic should work around while the excavation is happening. So they said that it's usually created these days with manual CAD drawings, but because all the rules exist and all the data exists for creating that, they created an automated solution for creating these TMPs with FME, and they thought that AR can play a really good role in this scenario, where you can just visualize a plan that was created automatically where it belongs. And maybe I can run this further. And you can check whether that works. Maybe the situation changed and it doesn't fit anymore, so you need some adjustments. So you can go and see whether it really works. Then a contractor can use this to come there and basically just build the real thing used based on that. So I'm imagining in the future we can have something like, because LiDAR can measure, can feel the scene, we can simply take a cone, place a real cone instead of the augmented one. An augmented one will feel that something is placed there and it will, I don't know, maybe show a firework exploding there, that the thing is gone and now replaced with the real one. And that's actually, I think it's quite possible, and we probably will see it very soon. Not FME AR, so I don't this plan, but maybe that will be possible in a couple of years. So you can see that. So all those things are not real. So that was another customer scenario. I really like this one. This is a scenario, well, I created it when we had our provincial elections last year in October, I think. I thought, well, how we can guarantee a safe social distancing while people come to vote. And this is an example where I make, I don't have any augmented reality at all. Oh no, I should say, no data at all at the beginning. I go to the field, that's the school close to my house, and I draw a line in FME Data Express, and that line goes as a request, as a URL to FME Server, where it's processed, and I get back an AR model. So I specify the line, and then I specify my location, submit the request, and get back how it will look like. So if I draw this line, how many people can fit and wait for their turn to vote.
I do love that you chose pirates.
Well, I was looking for a data set that would contain 3D people on 3D warehouse. It's that lots of, well, I didn't see this girl when I was walking there, so yeah, I don't see anything.
No, you can find.
Once we have headsets, then I can see them all. So and now you can see some people around the corner, and with LiDAR, we certainly can hide them around the corner so that they will be hidden.
Very cool.
And that's my spot in the line.
Usually where my spot is too, way at the end.
And here is another example. University of Denver, a researcher there, Jim Casey, asked me whether he could use augmented reality to recreate this internment camp for Japanese Americans during the World War II. And well, again, COVID paused the real field test for this, but I went to the closest sports field to visualize this tournament camp there, and I thought then it can be a history lesson for students. So you can recreate some environments and place them in some, well, open space and go and explore them. So it works, I believe, quite well. And you can add as many details as you want. So not just buildings, maybe some cars and I don't know, many details, and make it as realistic as you possibly can. And you can read the details about this project in the blog that we published a while ago, last year, I believe. You also can see in the area where I live. So now that's all with our demos. No, I have two more. Future plans for FME AR. Yes, we are working on Android support. I already saw some visualizations working there. So it is coming. It's just much, as I said, it's much harder than creating augmented reality for the, well, Apple platform. We are adding USDZ and GLTF support. USDZ, as I said, it's a native Apple format for augmented reality. And GLTF works really well on Android. We have both writers in FME, so you can write USDZ files out and view them on Apple devices. It's just we don't wrap them into FME AR files yet. Although we have a beta where it works, and I will show you the same train, well, not the same train, but the same location. USDZ, for example, supports animation. Well,
That's so cool.
quality of this video is not great, but you get the idea. And so
Yeah, that was a question that came into, does it support animation? So
yeah, so well, FME does not support animations. You would have to link an external model. But as you can see, what I did, so I created this model with FME and just added a train animation to FME. Hard to talk when when the trains are so loud. And added this USDZ animation to the FME AR file, because FME AR file is basically just a zip file currently with OBJ files and a small JSON file which explains where the model belongs. But instead of OBJs, we can place USDZ in the same archive. So and that will work. You will need the, well, we don't publish this beta yet, but it is coming, so you will be able to add animations to FME soon. Another reason why USDZ and GLTF, for that matter, also is great. It's a very short video here. Maybe look at the back of this Vaca transformer. I place it in the forest again. You see the reflections, and you can see that, like, maybe I go back here. The reflections of the real world. It's really amazing how it works. And that's another reason why you need LiDAR. The dog covers.
dogs always have the best time.
Getting quite confusing without LiDAR. So then we thought about adding attribute support. So you tap on an object and see the attributes, smart labels that will behave according to what you would like to see or how far they are from you. So for example, if it's an object is far, you don't need to know everything about it. Maybe just a label, that is something, a bigger label. But when you come closer, you get more details about that. And again, we're working on that. Then we thought, well, we have two apps, DX, Data Express, and Augmented Reality. Maybe for many scenarios, you don't need Data Express. Maybe we can integrate some of those capabilities inside AR. And actionable models, I already told you, when you tap and something is happening. And this is what is really great about FME. We don't have to code anything. All we have to add is just that tap action, and then the rest is defined by workspaces that we can create today. So there is, and they can be created by anyone. Again, no coding, just creating workspaces to, you can basically make a whole system, whole, AR GIS for your field device, and you decide how it will work. So yes, I hope you saw that we have lots of fun, and there are real business applications for augmented reality, and it's getting only better. So we are still in early stages, and I can imagine that in a few years it will be so much better. And I really, wait to see that future.
Yeah. I have to say too that like doing the webinar program here, all the AR webinars that we've done one other, and then we've kind of had many AR examples throughout other webinars. And they're actually some of our biggest like lead generating webinars. Like we actually get new business opportunities because we are embracing the value of AR. So if you are an organization who can take advantage of AR in its like early phase, you're going to be in a much better position to meet the demands of AR when they do come in, because like we are seeing that people are wanting AR. So yeah, try it out now, and then you'll be more prepared for future demands when they come in.
So how you can try it? Well, yes, again, for iOS devices, you can download and play with it right now and see what almost everything what I showed you is possible with FME AR for iOS, except the trains. For Android, we still have that app, the older app, which is 2 years old. You can visualize models, but we don't support scale 1-to-1, and we don't support location and orientation there. But FME is available to everyone to try, and if you're a customer, then just go ahead and create some FME AR models.
Yeah, so I threw this slide in last minute, Dimitri, because I realized this webinar is upcoming very quickly. So April 7th, we are doing an Ask Me Anything about AR with Dimitri and our two co-founders, Don and Dale. So if you haven't tried FME AR yet, or if you want to try FME AR with some of these examples we just showed, this is a really great opportunity for you to like try it out over the next couple of weeks, and then bring all your questions to this webinar, and we can give you that one-on-one support. Those webinars are a lot of fun. We actually invite people to come on the air live, so you have that option as well. So we hope to see you there on April 7th.
I have no idea what to expect. So.
Yeah. We've kept you busy, Dimitri. Oh yes, and then the World Fair. So if you enjoyed this webinar, you are going to love the World Fair. It is coming on May 4th to 14th. It's a completely free virtual event that we are doing, and it's everything FME. So you're gonna learn a ton, you're gonna meet new people, get inspired, and basically be like a kid with cotton candy, or a lizard with cotton candy. So you can register now at safe.com/world-fair, and we really hope to see you there because it's going to be a good time.
So thank you. So if you have to run, it's 9 o'clock. You can go. But if you have questions, we will stay for a while and answer a few questions. Thank you, everyone.
Yeah. Well, we ended on time. Good for us. Cool. Yes. Thank you so much, everyone. If we didn't get to your question, please, you can reach out to Dimitri on Twitter as well. I'll share out his handle at Dimitri@safe. You can also post it to the FME community at safe.com/community, or like I said, attend next week's webinar. But okay, so questions that came in. Can digital twins be created and visualized via FME AR, like HVAC instead of pipes?
Well, that's what I created, right? So I created the surface and called it a digital twin. So is it what the question was about? So when I just replaced the real asphalt with augmented one, or is it something more advanced than this? Maybe follow up with me. So my email is dmitry@safe.com.
Nice. Okay. Can we see the attribution of the assets, like ID numbers?
So at this point, we create just those labels, and you decide what will go there. And I will share the workspace with labeling, not that advanced labeling where you can create tables, because that is a huge workspace. Unfortunately, I will make a smaller one eventually, but I have a workspace where I can add some simple labels. I will share that one. But that's the plan when you will just tap on an object and get the attributes to see them, well, floating above the asset.
Okay. To see data underground, do they need to be 3D? And same question for above ground.
That's what the format supports. It supports 3D objects such as faces, solids, and surfaces. So even if they are flat, they still have to be 3D, or they have to be 3D. They can be flat, but well, there should be faces or surfaces or solids. Yeah.
So from Martin, what kind of 3D files do you use as an input?
Well, as long as we can read that data, so it doesn't really matter. So we support lots and lots of 3D, and again, it can be 2D, and we can transform it to 3D, as I said. We can make pipes, we can extrude if it's just a flat, polygon, we can extrude it. So that's what I do with poles, actually. I don't use pipe replacer. I replace a point with a circle, and then I extrude a circle and get a pole. So that's another way of creating 3D pipes. But we support, SketchUp, KML, Collada, Revit, IFC, multi-patches, so lots of 3D formats that we can read.
I think
OBJ, as long as we can bring them. So if we read them, then they can go to FME AR.
Yeah, I think that's the beauty of FME too, is we read a lot of different formats. So.
Yeah, it's about 400, 500 formats. Not all of them, of course, 3D. Some of them just tables. Some of them just web protocols. But if it's a 3D format, we can transform it. If it's 2D format, we can transform it to 3D. If it's a table, again, we can create geometry from it and transform to augmented reality. I had an example. I think I showed it last time when I show air quality. Air quality does not exist as a spatial object. It's just an index allocation. I submit allocation to a service, get back a number. Then I create a cylinder around myself and place that number on the walls and make the transparency a function of that number. So the worse the air quality, the less transparent the walls are. So, and that's how I create augmented reality from not geometry at all.
Cool. Okay, are the 3D objects used in the presented scenes freely available? So like the trains, the bridges, the traffic cones?
Yes, you will see, if you follow those videos, you will see the links, and some of them I take from sketchup.com. So yeah, they are usually Creative Commons, so I have to specify where I take it from. So, but I use usually two websites where I look for models if I don't have my own. It's sketchfab.com and 3D Warehouse. It's a Trimble storage for SketchUp models.
Nice. Okay, are you working on mixed reality? Not sure.
Well, I work on this, so you saw that. So I'd be curious to explore other possibilities. So I created some virtual reality data sets with 3JS library, JavaScript library for visualization in browsers. So we probably can, yeah, explore that area too. But I didn't create anything particular for mixed reality.
Nice. Maybe share some ideas there on what you want to see.
Yeah.
Okay, so this one, I'm not sure, it might be a rogue one. Instead of iOS or Android, what are the other high-dollar LiDAR cameras that may be useful in manholes?
That I don't know. Yeah, I don't have those devices. But it would be nice maybe to scan assets, right? So and then use AR to visualize them. Yeah, I certainly see that LiDAR devices can be used for preparing data.
Nice.
LiDAR devices or maybe drone videos where you can just create 3D models from footage that you get from videos.
That would be cool. Yes. Okay, so what do we have any transformers specially created for FME AR? Like, for instance, is there an FME AR labeler?
No, but it's a good idea. Well, I created one very simple transformer that creates viewpoints and centers models. But centering model is more universal than just for augmented reality. But I often have to take a model, scale it, rotate it, and center before placing it somewhere where it should go. So I created a very simple custom transformer for that. You probably will see it in the example that I will share.
Nice.
Yeah.
I chatted out to the audience as well. Steve Cyphers, listening in, gave some advice for you regarding the HoloLens. So it might be interesting to, I think it was Martin who mentioned the HoloLens as well. So thank you for sharing that insight. And okay, so maybe just a couple more. How about AR and more complicated objects? Can I visualize point cloud in AR or attach a mustache? That's funny.
Not the point clouds. We don't support that geometry. I know that LiDAR, well, in the phones can scan the scene. I think we would get more value if you would create a mesh, and that's possible. We actually made some tests with that, and it works. We just didn't include that into the product yet. The plan is to eventually allow you to scan the scene and create a mesh and create a 3D geometry as a part of maybe FME Data Express app. But we cannot visualize them yet. And more complicated as well. I recently created hair for Don. Don always makes lots of jokes about his hair. I created some hair for him. Well, I probably can use some. But yeah,
oh my goodness.
It don't look that great in FME AR at this point because we don't include all the visualization capabilities that, for example, USDZ provides. But again, it can be added later. So it's actually maybe a good question. We won't probably ever be the best visualization tool, the most realistic one for augmented reality, because we see our value in the attributes and maybe up-to-date delivery and processing power that we have in the cloud. So that's where our strong side really is. So because we have that whole infrastructure that allows you to really get access to the latest data and to richest model, the richest attribute set of the model. So that's where we will concentrate our efforts. And many of the visualization parts will just come naturally, automatically, once we upgrade to the latest versions of the existing libraries.
Mm-hmm. Don must have been devastated. That's really funny. AR hair for Don. Oh my goodness. That is great. Okay. I think it looks like questions have slowed down. So I'm sorry if I didn't get to yours. Like I said, please reach out on Twitter or on the FME community, or you can reach out to Dimitri as well. I know he gave out his email. So we hope we got, I think we hit most questions though. So hopefully that should be good. But we do hope to see you in that Ask Me Anything as well. We really hope you can take away some of the things we showed today, try it out, and then report back in that webinar in a few weeks' time and let us know how you're doing and where you need support. So we try to time it for that reason. Cool. Yeah, what do you think, Dimitri? Any?
I think it was good. Thank you everyone for coming today.
Awesome. Cool. Okay, so what I'll do is I'll turn off our webcams and we can close this down, but I'll leave it running for like another 5 minutes if anyone wants to save out any links or chat in any last questions. But Dimitri, you and I can go offline.